that should be live. Let's tell people in the usual channels. All right. I am streaming. People say I am not. Oh, it's still coding matcher. Yes. I mean, I didn't close the ID yet, so yeah. Let's check in real quick the other channel. Okay, cool. So let's see, where were we? So I implemented this thing, finding the auxiliary matches and initial matches. They now fully work because I implemented is match. No, that was already done. Match with and get auxiliary references. They're both implemented now. Your first test, like a unit test? Unit tests are not fun to write. Especially if your code isn't built for unit tests. Any tests. Huh. So those work now, and they work with reasonable... They work with really good accuracy, but not super high efficiency. Not as high as I hoped. If you look at this, actually I have it here as well. So we match 63% of all types, which is pretty similar to the amount of single matches we had here. So that's all good. Nice fonts. This is literally the RuneScape font. Like RuneScape. I just like we were talking about fonts, I think, in RTN chat. I found it. It doesn't work in an IDE, but works fine in Notepad. So there you go, RuneScape font. Yeah, so type matches a good amount. These field matches and stuff are kind of, I don't know. Why though? No, the question is why not? Huh? Why wouldn't you? By default it's like consolas or something, but this looks pretty nice, to be honest. I don't know, it probably doesn't look good if you're not full screen, because it's not terribly big, but I can probably... So 12 is the normal size. I can put it at 24. That should look decent. 18 is like 24 there. Beautiful. It's massive. I don't like it. All right. Yeah. Exactly. I am a man of science, as proven by this font. So I want to get this up, the type matches. Actually, no, I don't want to get the type matches up because that's already pretty good. It's like 63%. And this is like 67 were the ones, so we know like we quick matched, right? We're not going to find fully confident matches when we couldn't quick match against them in the first place. Unless there were multiple matches, right? Because there's this thing, multiple match percent. We could maybe get some of those, I don't know. Anyway, so these we can get up, the field, property, and method matches, because we know fields only exist inside a type. Like, makes sense. So if we know a field that is matched, or no, if you know a type that matched, like the fields inside them are going to be inside that type in both binaries. So that means we have a way smaller amount of types we need to check, essentially. Now, there's one thing I want to actually check myself real quick. There's a bunch of things that are not matched, but I want to know which ones they are. So I'm gonna put a breakpoint there. I want to check for myself, like the types that did not match. They're most likely going to be enums, I think. Matches. So types, unmatched source. Oh, so that's iterators. Yeah, that's already pretty awful. Iterator. Oh, that reminds me. No, these should actually match, because like these are iterators, which makes sense. They're not matched yet because it's hard to match those because they don't have many types. If you look at the fields, there's 2 of them. It's literally 2 integers. That's like useless to detect. To figure out to match these properly, we'd have to look at usage of these types. So in method bodies, to match these. And currently our match that uses method bodies is only the auxiliary matches, which isn't great. It's just like it just checks all the references, and the comparisons aren't very good, which is because if I look, where is the type reference here? The check, if you're comparing 2 internal references, is just always true, which is, I mean, that's going to be a lot of false, like everything is going to be a false positive as long as it votes inside the thing. So I guess the best way to improve this would be to like implement a check here where if you compare 2 types, it's actually going to check if the type themselves are equal or like matches, right? So if you look at matchable type, like we would use this code to compare them. Although, let me check. This isn't good because we check it ourselves. So I should probably remove this because that doesn't seem useful. It's literally the matchable type for itself. So like, yeah, because that would lead to recursion. So I'm gonna remove this and this and this. And that's not gonna lead to any changes in output. But we're still gonna match the same amount of stuff because it's literally useless check in this case because we're always checking 2 internal types. So if you look here, the matches, it's still 1644. And 0 LDs are also the same. So that's always just a useless check anyway. So that means now we can call is match candidate from type reference. However, that still means that we need to convert the signature to an actual type definition, and then look it up inside our match registry, which contains our types. So in here we have a lookup somewhere, probably. Do I? Hold on. The end lookup. Yes, here resolve. So you can pass in a dnlib reference, a dnlib definition, the correct one, of course, and it will look it up and will return the actual this thing. This is gonna crash if it doesn't exist, but if it's a dnlib def, so a definition, it should be in there. And it's going to return the same instance, like the same instance of the class that is used elsewhere. So we can check, we can compare by reference and stuff. So that's all good. So what I need to do is essentially inject this reference, a reference to match registry, into type reference. Like normally you do this to constructor, but then the thing is like, where is this all used, right? So we have here. It's like in all these are just created. Yeah. So basically it is just dependency injection. How do we do dependency injection? There are frameworks for this. Like there's tiny IOC, for instance, which is inversion of control, blah blah. Let me look it up. Tiny IOC. Autofac. I'll look it up as well. Autofac. I like tiny IOC because it's just one file and you can include it, and I think the license is really good as well. It's MIT, so it's good enough. If it's inside the source file, I don't even have to do anything myself. Let's see. Is it? Yeah, I can just literally copy paste this in and it will be fine. Actually, no, this isn't the license, is it? Hold on. What's the MIT license text? Yeah, it's not a full license, so I have to add it manually. How was dinner? It was great, thanks for asking. It was okay. It was like potatoes with like a burger with cheese in it, and then like the mashed apple thing. I don't know what it's called. It was pretty okay. I've had better. I've had worse. You make me hungry. I mean, I'll eat something. Get a snack. Oh, I don't have music on. I should probably fix that. I don't know if you can even hear it because it's kind of quiet, I realize. But there we go. Mashed apple. Well, I don't know what it's called. It's like, you know, hold on. Translate. So either this, apple sauce, or this. Compote? I don't know. It's Dutch, so. Mashed potatoes? The fuck? That's incorrect. Oh well. No, it's not that kind of. No, it's not that. It's basically, yeah, like mashed apples with like sugar in it and stuff. It's not a drink. Yeah. Apple compote. Yeah. Mashed potatoes. Yeah. Well, the thing is with like apple in Dutch is this, and potato is this. It's like earth potato. It's like earth apple, which is, I don't know. You also have like earth pear, which is apparently pear. What the fuck? Oh, really? Huh. Well, yeah, that's what we call an earth pear. Earth apple, yeah. Hey, lithium. That was an earth pear. Oh well. Dutch is weird. You probably should. I mean, it's like a. It's not a fruit. It's a vegetable. Like, what's the harm? All right. Anyway. Dutch is like German, just English? No. Dutch is like, I don't know, is it like a primitive version of German or like an evolved version of German? I don't know. It's like a potato in German is like Kartoffel or something. Yeah. It's I don't know, Dutch is weird. Kartoffel, yeah. I don't even see how you get to that word. Aardappel? Oh, really? Aardappel. Oh, so Dutch comes from Old German then. Because I have a Dutch friend and a German friend that says it's somewhat similar to like Lower German. But I don't know. Alright, so IOC. So I can do this, right? So it's an inversion of control containers. Basically, you have your container that you pass around, I guess, or you have like one instance of it. Problem is, if I just use one singleton, then I may as well just have a class with everything in it, right? like a state class or something, and have no like I have no thread safety at all. If I use autofac, it's I don't know. I mean, autofac and the tiny RC are probably going to be the same, but I mean, using a framework, you still have to get your instance somehow, which is just confuses me. Maybe you could make an instance that's thread local and only lives for. No, because then you have async being a problem. Load up containers with lambdas or people instances, blah blah. So where's the... Okay, so that's registering. You just register an instance. Yep, I have a container. I don't know if I like this. You know, I think this is kind of overkill to use a framework for this. Yeah, I think I'm just gonna pass everything through constructors and do like dependency injection myself, which is annoying, but Now the thing is, I want to pass in the match collection. If I pass in these registries, that's gonna be awful because I have to pass in multiple of them, and I have to do all the generic stuff, which is, as you can see, is a pain because you need to do this everywhere. Actually, isn't T... Doesn't T have a constraint? Pretty sure it does. Huh. Oh well. It doesn't. It shouldn't. So I'm gonna pass the entire match collection, I think. Which isn't great, because that's like... You're gonna... I should probably pass in like an interface that match collection implements, where I can get... where I have like read-only access, I think. I think that's better, because if I pass in like a match collection object, then I'll be able to register, like add in types, right? If you look at this registry, you can like match manual. You can add in you can match a type here if you want, and that's a state change, which is not good. I only want to do state changes like up the chain. I mean, I assume that's the good way of doing stuff anyway. All right. Have a nice meal. So I'm gonna make an interface, like I read-only match collection or something, or yeah, something like that. And I also want one for registry, because my registry here. So I have these registries, but they allow for writing as well, and I don't want that. I only want them to allow reading. So I want a match, another registry, I guess read-only match registry. I guess, I don't know. Anything. I can also go like proper OP and implement a iMatch registry interface. I could do that, but it seems, I don't know, not required, not needed. Oh yeah, match registry has like all these things as well, right? The types, T, NT, TN, lib. How do I import? Yes. Okay. Now these are things I can put in here. That's all fine. This is safe. Yeah. And then, oh, why? Okay. It's all good. I want to expose some methods like these. This one is matched. That's a good one. I'm gonna split this. That's easier. Match manual, resolving as well. That seems useful. Okay. Covariant, yeah, sure. I don't know. Oh, because it's only inputs, which means you can pass in. I don't know. It's covariant. That's good. Then you have these, which are for editing. Okay. Like all these change states, so if anything I should probably move this up because it's not state changing, so it somewhat like separates them. Boop. Okay. Cool. Now I can pass this I read only match registry to other stuff now. For instance, this I read only match collection can now implement. Oops, I'll move this over. These. Now put them in. Now, boop, boop, boop. No, just gets. Okay, and that is. Fuck. So I am accessing this, so but they needed to have a different name. Read only types, I guess. And then this is I read only match registry. Let's change this name to be proper. Okay. So you have a read-only match registry, which you can see our matches. You can't read from them, write to them, because they're IEnumerable and read-only dictionary. You can check if something is matched, and you can resolve a reference. Good. Then you have your read-only match collection. I'm not going to implement a concrete type for this. I'm just going to cast this one because it just doesn't seem useful. You need to rotate your phone and it will be full screen. Check. Okay. Oh, it works for me. So that's the read-only thing. Now I think maybe I should just make these internal. It doesn't seem to be useful to have this public, you know? What? Alright, fine. So maybe I make these internal. No, because I need to be able, like, in the end I want to implement the UI where I resolve the matches that haven't been, resolve the types that haven't been matched yet. And I need access to these then. So, yeah. Read-only match collection is done. So now I can pass this around. So if I look at my matchables, we have type reference. That's basically where I need it really. So I'm just gonna, I guess, inject it in the constructor. All right. And then in here. Oh yeah, I also want to configure like inject settings. So that's two things I need to inject everywhere. Maybe I really should be using dependency injection. Like proper dependency injection. I'm just gonna ignore that for now. So find the equivalent matchable type. Read-only types, resolve. Nah, this needs a proper implementation. Whoa, what the fuck? Whoa, calm down. What's going on? Oh, you can't. Autofac is kind of over. Yeah, I would use autofac, but it's a lot of effort, and basically you need to pass around your container and stuff, or you make like, I don't know. I'll look into it later, but right now. I'm gonna look at this first. Whoa, what the fuck? Hey, huh? Oh. Really? So... Okay, so I'm just gonna start with this. I don't need to pass in this because I already have that. Okay, so basically, first of all, I'm just gonna double check that they're both internals. Or I can just assert it. Debug asserts this dot kind is internal, and then other dot kind. Game streams. Why would you want to see me play games? I tried streaming games once, and it was a PlayStation 2 game, Burnout Takedown. It's a really nice game, but my microphone was way too quiet, and like nobody told me. And like nobody watched it either, so I just stopped playing at that point. Oh, that's cool. It says only used for precondition check. Huh. Okay. Oh, I just watch YouTube. I have a lot of subscriptions. So like even now I'm like over a day behind on my subscriptions because I haven't been reading them. It's like a full-time job to just catch up. So that's just what I usually do. Also, I don't really play games that much, so I don't have much to stream either. So I want both of them to be internal. That's what I assume. Right, see ya. I'll see. I definitely don't want to see me play Minecraft. That would be super boring. What was I doing here? So I need to compare the type reference, right? So essentially this type sig, type def. Basically this should be this def other def. Okay. So now we just compare those two definitions, which are, can I do this? Is that gonna complain here? No, okay. So I have these two definitions, right? I want to convert them into matchable types, which I do by using the match collection. Is the types, and then resolve this def. Oh. I would disagree. If you play vanilla, it's like real easy to just know most of the stuff in the game. Unless you mean like all the things you can do with redstone. And not just like knowing the function of all the components, but more like making everything or whatever. Then no, definitely not. It's not something you can keep on playing. Not for me at least. I know some people that are good builders and I really enjoy building, but I couldn't. Modato is pretty fun, but it's usually very goal driven. Like you have a quest line, you follow it, once you're done, game over, right? And I like playing that because I have a clear goal. But if I don't have a clear goal, it's like, yeah, you can make machines and stuff, but like, why? It's not like you can beat it, you know? Can't beat a game with no ending, so I don't know. Okay, so this should be something. Why is this always... Oh. There. That should be better. Otherwise it's always the same thing. Yeah. Also, just to be sure... This should never be hit. Like, shouldn't make sense. Oh, I love the quests. That's the reason why I play them. Also, the thing is, there's like two kinds of mod packs. You have the normal mod packs, and then you have the mod packs with equivalent exchange. And whenever they have equivalent exchange, or whatever you call it, I don't know what the new or old names are. Like, it's a completely different game. You don't play like to make machines and stuff. You just play to get as much EMC as you can. And then you just rush through the quest lines. Which is also kind of fun in a way. But it's different. Project E, yeah, exactly. That one. I really should be using the Penasy injection. I mean, really should be using like autofac or the IOC thing. Also, this track is really good. Treasure Town. Wait, I can just pass in this. What am I doing here? This. Hey, that should work now. It compiles. Wow, that's fast. To be honest, I didn't expect it to go that quick. Let's see. Run. Yes, there we go. That's what I was scared of. Stack Overflow. For mod packs, you just need like more RAM, don't you? And maybe a better CPU. Oh, is that a self-referential field? Wait, what is I? I is 1. So, the first field... Oh my god, really? Can't you just, like, go up a bit, maybe? Like, tell me what type is it? Oh, okay. It's an internal type, yeah, no shit. But what is the signature? It's a class signature. Come on. They should have like a thing where you can just remove some parts of the stack and go back. Like this is just painful. I don't know. Whatever, so it's checking if a field is a match candidate and it checks the type there. So basically what I want to do is check if it's already a match or something. I don't know. Is there even a point at going to the bottom? No, there's not. Whatever. Okay, so you have your type. That will check its field, which will do a type comparison. So essentially, maybe I want to cache this match. That's something I can do. So I don't need to recalculate this match candidate every time. The thing is, the space it's gonna take is gonna be n squared. Like if I have 10,000 types, it's gonna be 1,000,000 entries. I can't count, it's not 1,000,000, it's more. It's like 100 million, I think. And that 100 million is quite a bit. N squared space complexity is not good. Unless it's like really small. Like it's a bit or something. Which is gonna be, yeah. So I don't know. So there I'm just doing this and then this, and then this is calling type equality. Like, why would you have a self-referential? Okay, so what I'm gonna do then is only do this check if it's not the parent. No, that's not what I want. But I need to check somewhere if the type here match. It's like we don't want to have a loop like this. Yes. So where's the call stack? Right, so you have your field. Its match candidate maybe equal. mean, the problem is that it's self-referent. It's the field that refers to itself, like an singleton, for instance. So it's basically useless to check, yeah, this type. So I can make it null, or null allowed, nullable, whatever, which would indicate that it's basically itself. Like this. Type, come on. Field type equals, I probably need to see compare, I don't know. Field type equals field.declaring type. Right, now this needs to be different because I need to do like the signature or something. Yeah. So I want to see if this ever gets hit. If it doesn't, that means I need to just see compare. Yeah, it doesn't get hit. That's not good. Recursion counter? Ah, there's a recursion counter. Huh. Maybe I also need a recursion counter. So I need a C compare here. It's a struct luckily, so that makes it easier. No, it's not a C compare. Does this get hit, maybe? It should. Yes, it does. Okay, that's good. So we have this fields. Yeah, and that's self-referential. So only if they are not equal, I want to save type, right? But I don't know. I don't think making it nullable is a nice way. No, I'm gonna make a bool, right? Yeah. Private read-only bool refers to parents. No. Type is parent. Yes, there you go. And then it's not nullable anymore. Except like I make this there. Type is parent is this. Then if let's see, other, no, type is parent is not equal other. So that's basically another. Oh, soup, nice. So I only want to do this if we're not doing self-referential stuff, because that's bad. So if not this and let's do also not other dots type is. Actually, that would never occur because, you know, we already exit them. Okay. Now I'm only doing this here right now in field, so it's gonna. I don't know if it will. Yeah, it's still overflowing. Damn it. It's not gonna fix everything, of course. But where's the overflowing now is the question. Matchable. It's in a method. Oh, right, because the first parameter of a method can be this type. That's a problem. So if I just fix it the way I did now, by just doing type is parent, that's not a good fix because that doesn't really apply well to ultimate space complexity. It's space complexity of infinity. This type is parent thing won't work well on parameters for functions, I think. So the better way would be to cache the result, I think. But caching results is n squared space complexity, which means it will get really large. Though technically what we're saving is, I think, 16 bytes and a boolean. So let's say 32 bytes, like at most, I think. Or more, I don't know how dictionaries work. Let's say 64 bytes for each match we cache. So that's like, what am I saying? 64 bytes, and we'll say we do 10. That's times 10 million. Yeah, that's a lot of memory usage. That's not a thing I can do, I think. Except, of course, if we don't count the early exits. I don't know, man. Anyway, type is parent is not useful, I think. No, hold on, where can it happen? So it can happen here. It can happen in property. It can happen when the type, when you refer to your parent at, like, if it's an invalid type or something. Even then you can get an infinite loop if you have something. Hold on. So if you have a class that contains another clause or something that contains this. Okay, so just the y. So that would the type is parent wouldn't work because this is not the parent. It's one of the parents, but it's not the direct parent. So this would also cause an infinite loop. So no good, no good. Now what I saw in the endlib was that they have a recursion counter. I don't like recursion counter. It's not a perfect solution. The perfect solution would be to cache this, but I don't know, man. I don't like caching stuff like that. I feel like also we have this check here. If the type's parent and other type's parents. There has to be a better way to check this, because like this type of comparison, like checking if we're in the same type, like same goes with methods, right? If we check if the containing type has been matched for a method, the declaring type, that's also like a really good metric. But anyway, so this kind of comparison isn't great. Need to think here. Let me just look at the stack trace again for inspiration. Okay, so stack trace. So you got a field. Hey, what does these buttons do? Ah, cool. You got a field, right? You match candidate, so you check the type. Also, I'm gonna skip this track, it's a bit too much. Okay, so you have this type. Check your field, right? Check compare the field by doing the parent type. No, the like type of its whatever. Right? Maybe instead of doing this, the maybe equal thing, we check if the parent type of the type we have here is already matched, maybe. No, because if we have a nested type, that won't work. We would have to match all the nested types as well, which we do by matching methods through the auxiliary stuff. So that's not good. We can't do that. Type is equal, maybe equal to other, which does this, which does this. You do a match. Maybe I can check if they are already matched. Just that would fix it at least. The thing is, that's not good because we are looking for maybe equal. So if this fails, we would still have to return true. Another thing we can do, we can pass a boolean to every check here for is match candidate that says like, should we recurse down? That's something we could do, like just here, bool should recurse, and then because this is stuff that already recurses. So here you would do if should recurse return true. Actually, should not recurse. So that's a really quick check. Because the problem is that we are using... actually, another thing I can do is make sure we do not use... hold on. Yeah. Make sure we don't use this method from within the quick match. The is match candidate. Because that means we would never have this loop either, right? And then we can use it from here. The problem is we do need it. We do need it, I think. Maybe. I don't know. There should be a simple way to fix this. I feel like I'm just missing something. Like I need a bigger picture or something of like how everything works, because I can't remember it all at once. And that would help then. Or of course I can change this to not be whatever it is. We just need a way to eliminate types. That's just the thing. We just want a quick check. Is this, like, should we eliminate this, right? So I can just change the quick checks to not be as thorough by removing all maybe equal calls, such as these. So then what I would do is, oh, it's from, what is this? iMatchable dot is possible match or something. It's match candidate, yeah. There you go. So I would have to check all references to is maybe equal. Remove them from the match candidates. Which is a bad idea because it's used here. Maybe I can change is maybe equal to accept another reference here, right? Bool can call, no, bool deep, right? And by default it's false, but so if it's deep, then you do this, otherwise it's just true. That would work. Oh, you can simplify it? Oh, okay, yeah, that makes sense. Is maybe equal internal. So that's something I can do, just have a deep thing here, and then this can go. And then I should probably also document what deep does. Allow, what was this again? No. Allow using iMatchable dot is match candidate. Browse check with okay, and then other is type to compare to checks if now the thing is with the quick match, it's gonna return false if it's not the same, but that should be okay. It's maybe equal, but that's definitely not equal then, so. Okay, now where is this used? That's match candidate, so that's not good. This is not, so I can't do it here. Okay. That's match candidates. This is not, I think. No, it is. Oops. This one is not. No. I think that's all of them. So now it should not overflow the stack anymore. Aha. That's not good. No, it is good, because it means we caught a bug. That is null? How can that be null? Generic inst sig. Because it may be... Where did that come from? Is that... iComparable isn't internal. Oh, but I see. Because it's external, but that's internal, right? So, maybe I need to nest the type references in some way. Oh god, that's the thing. So iComparable is a corelib, but its generic parameter, the open dialog item, is internal. And if you look at here to get top level kind, I always, if it's internal, if anything is internal, I make it return internal. So when we compare them then, here, I assume that it is, I don't account for generics where the parent type is not internal. So I basically need to get like the leaf node or something. Yeah, that's the thing. So basically, so it's possible that the outer type is an internal. So that would be the array or the iComparable as you saw there. So in that case, we need to actually take the generic. So we need to get the kind here. Hold on, get top level. So maybe I can change this to also take a parameter to not allow this to be hit. So right now what I want to do, I want to check if the outer type is corelib. Wait, why is this always... That shouldn't always be corelib, right? Ho ho ho. What is generic sig? Oh, wait, that's a method parameter. Yeah, okay, so that's always corelib, but this isn't because it could be anything. So instead of just having one kind, I would have like a sort of, is it a linked list of kinds? I don't know. What's the way to solve it? So let me take my notepad again. Essentially, you can have I collection of my type. So that would become essentially, can I? No. That would become corelib, and then in there we get a my type, right? if we want, what are other cases? We have arrays, right? So you have my type array. That's also kind of like a generic. It's like for lib my type. Now we just my type. Oh, not my type. Internal. If you just have my type, that would of course be internal. If you just have, I know, like an int, that would be for lib. So that's what we want basically. So it's like, also this could be multiple as well. Huh. So that's a bunch of possibilities. Right now I'm just turning these into internal because there's an internal in there, right? So basically I would have like a self-reference, like it would be nested then, like type reference containing multiple type references, I guess. Is that a list or an array? Generics there. It's gonna be generics only. It's no way to otherwise have this. Like I'm gonna act like this is generic as well. So you have non-leaf and you have leaf as well. A non-leaf basically has a next sig, so it's like, for instance, array has like one generic parameter, I guess. And then you have leaf as well, which is like something special apparently, I don't know. Generic leaf, yeah, but the thing is with leaf you can't just get the next. Oh no, they are last in the type signature. Oh, that's what leaf means, okay. But there is still generic, which has like generic parameters. Right, but it's abstract at least, so we need to do the implementations, which is generic variable, which I think has a type. No. Generic int sig has types, yeah. But generic sig does not. So you get the signature for this. Then that's another thing. What if you have a nested generic? That's gonna be awful as well. Like if you have my, no, that's not gonna be possible, hopefully. Like you can't do this, right? Because my type would need a generic parameter, so that's not gonna be a problem. Nested generics of themselves. Generics that nest themselves, it's not possible. Let's see. Let me check Discord real quick, just quick peek. Everything seems to be fine. Okay. Cool. So I want to know if there are nested generics, right? First of all, if there's a non-leaf signature, there is one. I know there is one. Right? It's gonna private static. Get nested. No type sig, yeah. How do you return an empty enumerable? Is like enumerable not empty? Yeah, okay. Type reference. Okay, cool. So that's the default. Then you have your generic var is just a var. You have generic type sig. That's the one you want. So you're gonna need generic sig dot generic arguments dot select get sig. No, get sig kind. What's the problem? Kind. Oh, okay. That accepts the type signature. So I can just do new type reference and it takes the arguments and the match collection. Okay. Why? Damn it. Maybe I should take one type sig. Okay. Okay, anyway. So generic we need generic arguments, and I think that is actually the only thing. If you look here, oh, we have arrays as well. Yeah, the non-leave ones. Yeah. Okay, so then we only have one, so it's like I don't know if you can do an empty array or just an enumerable of one. I don't know how that works. I don't know if there's an efficient way of doing that. Passing a single item. You can do an array, but oh, it's this as well. Oh, that's actually something. Yeah. I like that. This too. Now what's this? Yeah. Dot yield. I'm just gonna take this. And let's see, match utils, I guess. I don't know. Buy and share alike. Share alike. That means I have to share my code? Okay, you know what? I'm gonna write it myself. Public static t yields? No, to enumerate. Just the yields of t. Where I give in a t. Oh no, that's an enumerable. Yeah. T item, then yield return t. No item. There. Cool. So now I can use just yield. Actually, it should be this. So new type reference dot yield. Why is this not working? Oh, I need to pass in the match collection. Okay. That should be all cases. I don't know for sure. Well, it says what implements it, right? So you have leaf sig and non-leaf sig. So these are the ones I need to think about. Well, a leaf sig has a next method, so. Alright, then you have a non-leaf sig. And then leaf sig is like these. These are just like actual generics. We don't know what their value is. Sentinel, I have no clue what that is. This one is useful. And these are just, I don't even know. Should be fine. Take a drink. Okay. So now that should work. In fact, I can probably inline this. I don't know if it's a good idea, but haha, no. Oh, there we go. I want to change this though. Link to code. Oh, because it's to array. Can I change the switch to be... No. Okay, I'm gonna do it a different way. Switch sig. I copy these. And then... No. I'm gonna remove the to array, remove these, change this to a new array of no items. It's gonna be just an array with one item. There. And then this will need to array. That should be good. Gonna make sure it's formatted. Okay. Should be good. So that's its generics then. And then in here, I don't need to care about this anymore, right? So I can, it's a generic signature. So instead of the generic arguments, hold on, I'm just gonna return core lib type, I guess. Same here. Yeah, so all these are curl lib types. Basically means they're just default built-in stuff. Non-leaf, I don't know actually about this one. To be honest, this shouldn't be non. I think I can get rid of this. Then generic var and generic sig, they're just built-in stuff. Like generic sig is a base class. Hold on, generic var base. I don't know. Generic var is just like a method one, I think, or whatever. Generic inst sig. God. Can I just like, hold on. What if I do this, right? Ah, no, that's gonna crash because, yeah. Wait, how does it know when it's a core lib type then? Because if you have an integer, it's not going to be handled by this, like, at all. It's going to be a type ref. Huh? How did I do that? That get next. How? Oh god, I'm so confused. Can I put a breakpoint there? No. I'm just gonna run it and see what happens. Okay, so this is because it's an array signature. SZ array sig. The thing is, we have non-leaf here. But there's, if you have your own generic, it's going to be non-leaf as well. I think. I would have to check the spec for this. I don't know how this is defined. Hold on. Do I have my plugin installed in the nspy? Yes, okay. Is it debug? Yes, good. Okay, I need a generic then. Is there a generic in here? No. In here, yes, probably. This is a generic. Oh, it's just gonna be a type def, of course. What am I doing? So that's a type def, yeah. What if I find a collection or something that's used? What's this? What's that even? Oh. That's a type ref because it refers to system. It's not good. How do I detect it if it's from corelib? Is there a corelib? Is corelib type or something? Ha! Null if it's not known. So if it's null, we don't know, and I want it to be false, then. So like this. So why did this throw again? Because it was a non-leaf sig, right? Yeah, it's an array sig. So what I'm gonna do, I'm gonna just comment all these out for now, right? And then array sig. That was SC array sig, yeah. Gonna see when it crashes now. C mod reg. What? Okay, what is this then? That's a dictionary. Oh, C mod red qsig. Yeah, so then I just need next. Oh no, I'm gonna assume, I'm just gonna turn that into corelib. There. Calling, not calling sig, it's to call a type of calling, like a std call. What's it called again? I don't remember. Calling convention. Okay, let's see what's gonna crash on now. Generic inst sig, yeah, so this is an actual dictionary. So it's a generic inst sig. Then we have generic type here, that's a class sig, yeah. So then I would recurse on what was it? Oh, sig. Generic type. Get sig kind. There. What's the problem here? Oh, okay. Let's see. Now we have a generic mvar, which is a t. So that's always okay. Come on, okay. Run again. Now we have a birefsig, which is Huh. Where's that from? It's a parameter? Oh, I see. So it's basically also a wrapper, yeah. Okay, let's see. I'm gonna get all of them at this rate, probably. Generic var, and a generic var is A. Where does it come from? Oh, it comes from A array. Okay, hold on. So it's a generic var, and it has probably a type like generic param. No. Element type. But what is it exactly? I don't really understand. Hold on, so you have this signature, it's just generic var, and it comes from this, from the next, right? Because it's a CZ array signature over apparently a generic. And that A is then an actual generic. Right? Oh, I have the thing open, don't I? Yeah, I can. Is that the same? Okay, that's 22. It's 9.7. What's this from? Oh, no module. Okay, cool. Module. And this is 9.1. Okay, so I need to open 9.1 then. Okay. And what's some MD token? I can copy that. 1. Oh, I'm looking at the module. Okay. Field, whatever. So raw, it's this. I'm gonna copy value. Okay. So I had to open 91. Let's see. Open. Where is this? Okay, it's in D. Unsorted, temp, executable, stable, and it was 91. Okay, so it's this. Oh, it's the wrong one. I need to decrypt it, yeah. Okay, there. So it's actually generic. Like it's the generic parameter of the class. Yeah. So it's a generic var. Okay. Generic parameter of type. Yeah. Generic type parameter, I guess. Okay, cool. That's the next error. No, it's a pointer sig. Oh. What? No, I didn't talk to you, Google. Okay. It's a pointer signature. That's also just a wrapper, I guess. Oops. Because it's, yeah, it's a pointer. It's basically like the reference thing by ref. And that's pointer sig. Typed reference of array sig. Yeah. And that's a generic. That's a multi-dimensional array, but it's still one type, so it's fine. Huh? What's this? Huh? Did I fail an assertion? What the fuck? Oh, that's null again. What's the signature? Obfuscator T. It's a generic inst sig. Yeah? If I look at this, generic inst sig would be of the generic type. So maybe yeah, I would do a generic type here instead of storing the sig itself. If sig is generic inst sig. There's also inst method sig, of course. Why wouldn't there be? Sig is sig.generic. Huh? Wait, what was it? Generic arguments, but it's next? No, it's not next, is it? Oh crap. I don't remember. Okay, I'm just gonna put a breakpoint here. And we'll see what it is. So I remember seeing it in the inspector thing. Oh, but here it works, of course. Generic type. Okay. What? Wait. What's the real type? Because I say generic instsig, but there's more to it, I think. What is the real type of this? Generic instsig. Oh, I'm an idiot. Okay. Yeah. Generic type, okay. So that would work then, maybe. Oh, hey, it's matching and stuff. Oh, argument out of range. What is arg? List change. That's an event handler, yeah. Right. And this auxiliary reference thing. So this is a matchable type. So in the auxiliary shit, I need to, where is it? So events, I shouldn't do that just yet. Like this, and I think the same in method. I'm surprised I didn't hit this code before. Oh, is it working? No? Yes? This took a long time, didn't it? 2 seconds, yeah. Okay, but what did I actually change now? Oh yeah, I refactored part of type reference. And now top level kind isn't in use anymore. So in deep, whatever this is, I need to change stuff. Right, so is maybe equal. Now I need to take into account what the types are of the, like, children. Let's see, I can remove these. Whoops. Okay. Alright, so we have our generics here. They're not used right now. Right. So if I look at maybe equal, essentially, statement body, yes. I need to also do it for all of the children. So var equals var children equal is generics dot all wait. Oh, I need to do it for the other as well. Because I am gonna assume the generics are the same. Okay, so I can start here, right? If generics.length is not other.generics.length, then return false. Right? So now generics are equal. Checked that before. Let me check this real quick. Okay. Right. Generics are equal. Check this before. Check before. So now I can basically just loop over all the generics and check if they're equal. It'd be really nice if you didn't need the brackets for ifs. That's just bad, I think. It's not really needed. So I'm gonna just do a for loop over the length of generics. Generic length. So if this may be equal to other generics I. Okay. It's not maybe equal, return false. Cool. And then return true because everything, all other stuff was successful. Now you want this to be a link expression. Now this can be any. Now that can go, right? Ah, well, no, I need to generic. So I can zip them probably. That's a way to optimize it. Pretty sure it's zip with other generics and then all. Okay, why is this not working? Okay, I'm gonna need to look up how zip works. C# zip. Nope. Zip. How does that work? Oh no no no! You return a boolean, don't you? You make your own thing that zips, right? So you have generics, and then you, yeah, there you go. Generic 1, generic 2, and then you do generic 1 dot. This may be equal to generic 2, then dot all. There you go. Let's see, maybe I should change this to reference 1. No. Okay, also I don't think calling it generics is correct. Because it's not a generic, it's more like a next type. Next types. But I call it generics in here. No, type 2. Cool. There we go. So you zip those, and then if they're all true, return true, otherwise false. So this is basically checking that the types are equal. And the thing is, I'm doing maybe equal here. I need to pass in deep as well. Yeah. It should be impossible now to have a recursive thing. Yeah, it shouldn't be possible. Cool. Let's hope this works. Okay. Now I don't know if anything actually changed. Let me just copy this over. Oh, I don't have the old thing open, do I? Oh, I do. Okay. Okay, close this. Oop. Amount dropped due to unconfidence. Is that a percentage? Oh, it's 0, and that's 0.003. That does not seem... That's strange. Very strange. There's like one type, so that's fine, but it's like kind of strange. So this is good. If you look here, our 0 matches and multiple matches both went down, and our single matches went up. So match more stuff now. That's good. And then if you look here, you have slightly more type matches. A lot more field matches. That's really good. Well, a lot more. It's not a lot. It's a few percent. But property matches went up quite a bit. Sounds like success to me. Oops, that's not what I wanted to open. Ah. Shh, close. Okay. Now, why did I do this? I completely forgot, but let's just check out results. Let's see. So, what did I? Let me just look at my changes, because. Oh yeah, I passed down those, and then. Hold on. I can go. Oh yeah, right, so implement type check in something. Oh, also we're doing this only in, yeah, we're only doing this only in match with, not in match candidates. Which means that we're not narrowing down more candidates. We're only improving the confidence. No, we're improving our confidence metric because it's going to be less confident now if the types actually differ of like fields and stuff and methods and functions. Types is what I mean, yeah. Okay, so all other stuff besides the very first step will be better now. Yeah, that's why. I know what I'm doing. Sometimes. Improve type reference. I don't need this anymore. Okay, so let me just double check. This I don't need anymore, top level type. I can go. Let me check this. Okay. There was another thing I was gonna do. I forgot. Oh yeah, I was gonna check here. So we have this deep, right? This may be equaling internal. So this is basically just gonna call is match candidate. And that's it. The rest is just setup, like get the type def, resolve them, call is match candidate. Now let me run a debug check just to make sure no asserts get hit. Actually, they wouldn't get hit otherwise either. Okay. Good. Good. Now I don't like how this takes 3 seconds. That's so long. That's very long. But I don't know if that's only for debug. Maybe release is better. A 1.6? I don't know. It's only a single step, that's at least something. But in any case, something became a lot slower. Because we're doing the deep check now, so it's probably that. And that deep check is calling is match candidate loss, right? Which we don't cache, because that would take a lot of space. So we're just doing more work, I guess. It's fair to say. Alright, let's commit this. Now next step would be just more steps. Like one step I want to do is checking parents to make sure that's not something we can improve on. I'm just gonna change this to print. There. Also, I'm gonna check my to-dos real quick because there's a bunch of stuff. Well, events, I guess. What is this? Oh, I can improve these. Maybe. Right. So first of all, where do I use those? I remember setting this earlier. So, where not already matched. So you want to find... Thing is, that's with T, right? So it's not generic. We can only do this. We would have to implement it in here, in the predicate. So I would need to move this up somewhere else. This is good. Although, no, I think the optimization was check if it's already in the registry. And if it is, we don't need to call this exclusive match thing. I think. Yeah, because if you have two lists and they both have an enum, but one of the enums was already matched, then that's fine. So I would have to update this predicate. Oh, what? No, what I can do is maybe equal. I can check if this is already in. This is already matched before, right? Yeah. Like, but I have the match collection, right? Because this is a type reference. Sig. So if kind is internal, yeah, so I can check if it's already matched. So yeah. This should be good. No, the thing is maybe equal. Is gonna return true otherwise. Like anyway, I mean. So if it's matched, that means this all is true anyway. So this is useless. That's not what I'm doing. Need to do. It's here. I first need to eliminate the matches that have already been matched somehow. So I need to like give a priority predicate or something. So I need to remove the ones from like interfaces that already are matched. So where I finance source. Do I have source or something? No, what's it called? Match collection. I'm not storing that, am I? Match collection. It's an interface, so that's the type. I It's a type reference. So essentially you would have to, no, I'm not going to do this later. I don't know how I would do this. No, that's useless. It's only useful for auxiliary, so I don't need to do this here. This one is probably fine. So it's auxiliary. Oh god. Okay. So it's in here. So find the auxiliary matches. So you have these exclusive matches. Wait, I was doing exclusive there, aren't? So it was actually relevant there, wasn't it? Because I want, it's not exclusive matches that I want. What was I'm so confused. What was I doing? Where any matches is probably what I want here. Yeah, that's what I want there. So it's gonna improve my results. Okay, what did I change in here? Oh yeah, of course. Where any matches, and then what did I change here? Is it comments? Yes. Or remove something here. Comments. Okay. So if I run this, nothing functionally changed except for that thing, which means my stats should be better. Are they better? Yeah, more matches here. More method matches, yes. This is slightly better. That's better. This is the same. This went down quite a bit. Oh, that's good. The one with 0 matches went down because I removed, yeah. That's good. I really should add a check to check how many incorrect matches we have. I'm gonna do that right now. Okay, so how do I do this? Collection dot types. Oh no. I'm gonna okay. Okay, sorry. So types, and I want the amount. So collection dot types matches where, no, counts, where pair dot key dot name. Oh, whoops. I should probably... There. Okay. That should be fine. Now if I run this, I will also know how many are incorrect, which shouldn't be much. Oof. That's not good. Although for methods it should be okay, because those are usually state machines. Same for types, actually. I'm gonna copy this over. Replace that here. $200 methods, 300 methods. That's not great. That really isn't great. I want to know why that is, because that's not good. Why would it be so different? Maybe a mismatch in type would cause that? So I'm gonna... Just gonna do this. Oh, I don't need that actually, just this. Okay, I want to know what these are, because that's weird. Oh, of course, it's all Eastfuscator. How about these? Yeah, they're all obfuscated names. Okay, good, because they're random, and that's expected. Alright. Yeah, oh, thank God. I thought something was actually wrong. Now, I changed this out, right? That was where any. I'm gonna change this back to exclusive and see if there's a difference in stats. Okay, I'm gonna copy. That seems to be the same, yeah. There's no extra wrong matches. There. So yeah, less zero matches, which is good, and no different ones. No wrong ones, at least. Or additional wrong ones. So the change is a good change. Very good change. Cool. Okay, also I made a typo, I noticed. Ignore if input is obfuscated. I can do this only with this debug as well if I want. If debug. Okay. Nah, should be fine. Cool. I also kind of want to make this like, hold on, first of all, string formats. I want to make this like a, not percentage, but like how many out of how many. There you go. Now it should be slightly better again. Yeah, there you go. Out of 7 matched properties, 70, none of them are different names. Good. Cool. That's some good statistics. Okay. So, there was another thing. So, where any matches? So I was using it in... Find exclusive matches here is possibly a problem, right? So that's what I want to do. So I want to eliminate the ones that are already matched, because they are, like, I mean, already good, right? So I can't take a read-only list. Well, I would need to make a new list. Here's a problem, right? Don't know if that's what I want. Well, I can take an IEnumerable and just enumerate it twice, which is fine because these are arrays. Also, this accepts, what does it accept? Yeah, it assumes you pass in a list, so... So... I'm not gonna accept read-only lists, I'm just gonna accept lists and modify them. Although that's an array. Okay, I can live with that. Ah, no, that's a problem. Because you can't modify arrays. Or you can't resize them, at least. You need to make a copy. That's annoying. Okay, yeah, I'll have to just allocate stuff then. Or I can do stack-alloc, but I don't like doing that. Ah, it's so much cheap allocations. So basically, for every matchable in the source that's already matched... Wait, hold on. First, where is this used? Is that even gonna happen? Yes, it's gonna happen. Okay. So if that is already matched, we immediately return it, yield return it, and we don't pass it to this find exclusive matches. So where is that used? Okay. So yeah, if it's already matched. The thing is, if it's already matched, then this gets hit. But that's fine, because that's not the only side effect. The side effect is also that the other things are gonna match more easily, because they're gonna become exclusive when they weren't before the matches. So that's good. So I should yield return the ones that are already matched. Though technically, I don't even need to do that. Find new exclusive matches. Yeah, okay. So I'm not gonna return find exclusive matches in that it doesn't return matches that were already known. There. So essentially, the source becomes a new source for new source equals source where that's a matchable. Of course it's not. Don't know what kind it is. Gonna add a method to this. I matchable. There. So it's an overload. What's this? So switch I. Oop, no. Wait, no. I'm fucking hell. Sorry. I don't need to do it in here. I need to do it in the match collection. Which is massive now. Solve the endlib ref. Private. Does it need to be private? I don't know. Can be public. I'll keep it private. Match. No, bool is matched. No. How did I call it? Is matched, yeah. I matchable. Switch matchable case. Wait, that's how a switch works, right? Like this? Okay. So matchable fields. Return field. Oh, the thing is, it's only no, to find match, yeah. Because I also need to know what it matches to, and I can't do field.isMatch because that only checks for the source, right? So this would be isMatched source, actually, unless I do isMatched, I don't know, something else. So find match. So I have to match. Matches. Let's try get value. Why is this? No, get. This get value to true. No. Come on. I guess try get value then. Shame. No, try get value. Get value of field out var f or no. There we go. Why is this possible null reference? What's the null reference? Field. Field should never be null. Key is null. Hold on. Oh, cause this? No, well, hold on. That? No. That? Matches? What's the? Oh, I see. Of course, that's nullable type. Field property method type. So that's P. This is M T. Okay. There you go. And then default return, no, throw new index, no, parameter out of range, argument out of range, yes. Okay. Now this can become a switch expression. 8 my comments. Okay. So find match, that's good, that's what I need now. Where? I don't need to match, what am I doing? No, hold on. Hold on. So matches is as so select find match. Okay, I'm just gonna do it simple, start with two lists. Var new source is new list of I matchable and new target. Okay, now we're gonna loop over source for so source equals source I. If source item, no, if var principal match equals why is this not working? Oh, because that's static. This cannot be static then. Okay. So you have a possible match, and if that is not null, that's bad. No, that's good. So that means we don't need to add it, right? Also, no. Okay, so I'm gonna add there. Okay, it should be the same object. And now this can turn into a link. No, not this kind of link. That's the bad link. I don't want that link. I want this link. Okay. Oh my god, why? This is such a pain. All right, so now that's the ones that are like whitelist, like blacklisted, I guess. So the ones I don't need. So now I'm gonna loop over both. Oh, man, this is such a simple thing. Why am I having? It's probably late. Too late for me. So what I want to do is I want to make a new list where there's no matches in them, right? So that's our new list. Yeah. Source.forEach matchable if matched match sources dot contains come on, match sources, and then item 1 equals matchable. No, match source dot any item 1 equals matchable. So if that's in there, no, if that's not in there, you just add it. New source add matchable. Now, same happens for the other thing. Fine, you can turn it around. New targets. Okay. It's ugly. It's probably slow. There we go. I'm gonna just run it and see if it works. Because I have the stats, so I can tell immediately if something is awfully wrong. Huh? Hold on. Huh? That does not seem right. What happened? I'm matching way more methods. Huh? How come there's none where the names are wrong? Was I just doing it bad before? Huh? This is really weird. I just fixed a bug I didn't know I had, even though I checked. Or something is really, really wrong. Okay, let me just add this first, right? Because this is a massive improvement. If it's not a bug. Like, there's less types that weren't matched. No fields are wrong now. And we're just matching more stuff in general. Like, what the fuck? That's so strange. The initial stage is the same as expected. What the hell? That's just weird. Okay, so... But like there weren't randomized names, method names. Are they just not matched anymore? Oh yeah, there's also, hold on, multiple, if the amounts are up to this thing. Yeah, that's yeah, it just needs to be different. Yeah, that's the percentage, okay. That's not a percentage. Okay, cool. So that is just, there's only 2 now, which makes sense, because there's only 2 that are random. But there were also, no, 2 that I'm sure that are random. Huh? It's taking longer. So that's 2 of them, and it is exactly the ones I expected. So maybe it just didn't get to those? Or it generally just was a bug that matched the wrong thing. Because it didn't have enough info. Jesus, okay. Well. Well, I'm matching. My matches were going from 65% to 80%, which is a massive increase. Like, holy crap. That's good. I don't know about the others. Let's see. Oh, fields went up as well. Okay, I thought it went down. Up, up, up. Holy fuck, man. I have the same amount of... yeah. That's just... wow. Okay. Jesus. Okay. So... I'm just... huh? Okay, so first of all, also performance didn't really hurt that much, did it? If I run this, I don't think performance really died. Okay, maybe a little bit. It takes a second now. Wait, it was less before, wasn't it? Oh no, this... huh? Did it actually speed up? It shouldn't have. There's no way that speeds it up. Whatever. So... well... okay. Maybe this is some magic sauce thing. I don't know what it actually makes. Well, anyway. Just massively improved the matching. By 15%. Oh, for types. Like 10% for fields. 10% for methods. Jesus, okay. And all of the names are correct as well. That's so hard to believe. Well... so this... hold on. Find exclusive. So if I just turn this back, it's gonna be worse. Just want to double check, because this is just a bit hard to believe. That's too wrong, yeah. And this is a little bit less, but not by much. Okay, okay. It's, yes. That's the only usage. Okay, that's good, because that's the... it's kind of a dangerous method. I don't want to use it too much. But, damn. Holy crap. I don't think it's that ugly, so I think I'm gonna remove this. This is bad though. Okay. Alright, so that's just a big improvement. Now, let's see if... wait, what was I gonna... oh yeah, let's see if this can be improved. Because I want to... I've changed this already, so may as well change this bit as well. Right, let's see that here. I'm gonna change this to be a list to match the other thing. This one. Maybe I should also just print the stats from the matches after this, because I'm pretty curious about the actual stats. This is useless as well, actually. Amount of types. Oh, type, no, this would be types checked. Oh, this is a good song. Okay, right, should be good. I'll just run this, get new stats. Oh, that should have a new line after it. And this can go. Okay, let's run it again. No, I'm gonna, I know I keep making stupid changes, but I'm gonna pass in stage here, matches after stage this, and then I can here. There we go. Okay. That satisfies my OCD. All right. So copy this. Oops. I'm gonna remove the time stuff. Oops. So there we just match a bunch of types, and then here we have the types and fields and all that stuff, which is really nice. Okay. I don't like this, to be honest, like dropping stuff because we're not confident. That sounds like a bug. Because we matched something we shouldn't have matched. But I don't think we do many more expensive checks inside the confidence check. But it doesn't hurt anyway, so. Alright, I should probably close the stream because no one's watching anyway. There's some people in chat apparently, but I don't know if they're actually, I don't know, watching. Yeah, because this is really cool. Actually, there's one more thing I could do right now, and that's the check I said before, where you check the parents and match it. Maybe first of all just commit this. Improve, was it type? Hold on, auxiliary check, yeah. So that's a really good improvement, dude. Oh, so happy with this. Let's see, what else did I change? That's just good, okay. I renamed this to isMatchedSource. Now that's find new exclusive instead of just find exclusive. Oh, that's maybe why. No, that shouldn't change performance because they always quick exit. Also, I wonder if adding events will cause the matched types to go up. That would be cool. So find match. Did I change that? Oh no, I implemented that just now. That should be get match or something, right? That should be good. Matchable types. I don't use this anymore. Wasn't used anyway, so there. Is matched source. Yep. Cool. Improve auxiliary check. Some big wins. Die. Okay. Cool. Alright, so now, okay, to be honest, I'm not really a fan anymore of this thing. Like where I'm gonna change them to statement bodies again. Because I can't collapse them otherwise. Let's see, let me just check that I can collapse everything. Yeah. Yep. Okay. Good. So we have get auxiliary matches. And then after this, I assume private void, no, public void. Find, no, gets parent matches. Get parent matches. Find parent matches. So essentially what we're doing is we're getting the parents of every type or property or field or method, and if that's not matched already, we just match it because we already matched the method, so we know the parent is going to be the same. So that should match a lot of types. And then afterwards, if you have many types matched, we can do the same, but like with the children maybe. I don't know if that's gonna help because we already did the auxiliary matches. Although maybe we can do auxiliary matches from the parents we match here. Do we get nulls in here? No, right? Okay, let's just go over them. So first of all, let's start with fields. Matches for each field match. Although I can do this. Key value. So if key dot is no fields I should move this into the registry, to be honest, because I'm just gonna repeat this. Is matched source key. Well, no, of course it's gonna be because I'm looping over that. Yeah. Key dot dn with def, and then parents. No, declaring type, right? So I want to do types dot resolve. Now this could be null, but it shouldn't be if this optimization is useless. So if parent type is null, no, if it's not null, if it's null, so it's false. Oh, so it's resolve here, but it could be. Maybe I should make try resolve, right? And this is a question mark. Oh no, because it's Can use a bool. No, it's always gonna resolve, of course. What am I doing? So, declaring type, resolve, yeah. I need to check if it's matched, not if it exists. Types.is matched source. So if it is not one, we print out declaring type. And maybe break as well. Come on, break. It never gets hit. Like never. Which means that the declaring types are always already resolved. Let me just double check. I'm gonna put breakpoint here. Yeah, it's not hit. So this is a useless optimization because it never happens. Now, in which case would it actually happen? Oh yeah, that's true. So let me explain real quick. So you can have like a class which has field X, and then another class inside of it with a field Y. So for this, it's never going to be this because this. So if we do find parent matches on this field, it would find this, which is already matched. Hold on, is it already matched? I need to think why. So we have like 20% of types that aren't matched yet. Why are they not matched? Like, what reason is there? Which types are it, and why wouldn't I get to them? First of all, you have your ease types, of course. Private implementation details, that makes sense. Although I can match these by doing like a reference type thing. Yeah. Well, I can do those. Actually, don't worry about it. I will fix those. Now, that's a nested type. Right. So they are initialized, I guess. That's not a nested type. Let me get the MD token. Copy. Right, that's player VS. Now, it's a top level class. That's good. Maybe I can just do another top level, like matched kind of thing. Because if I find this in top level... Oh, what is the difference between this and like player test maybe? Oh, okay. They have more fields. Then it should find them. Because it has this as a base class. Yeah, because now the base class is found. So I think if I just do another path for like top level matches, or I go through all types and find the ones that aren't matched yet and see if they have a single perfect match. Yeah, that should work. So yeah. So that's the first one I did, right? So that's the stage one. Find initial matches. Why can't I go to the declaration here? Okay. So that's find initial matches. So that's the initial ones. It's literally just only finding top level. However, if I remove this, what will happen? Will it really be worse? Actually kind of curious, because I did top level only, right? Yikes. So we have a lot of incorrect matches now. We match more when we match incorrect ones. So you take the old one next to it. We do match more. Not that many more. Like 5% of types. It's like 150, but like a third of those are correct. Except for the methods and stuff. Unless those are actually random names, which would make sense. I want to check, because I don't know if it's correct. Or it may be just actually different names. I could just check easily. I could just check for every type how many there are that don't have a different name. Wait, what am I checking right now? The incorrect ones, right? What's this? I clicked the wrong button. Okay. So yeah, they're all Easter Skater, like, of course. And those names are different. But that seems to be like the random parts of it, right? Oh, hold on. Huh? I didn't know that had a candidate list. What? Oh, that's new. Let me find that real quick. See the token M. Whoa, hold on. Why is this not? Huh? Wait, did I close my other window? Fuck. No, this is almost correct. Yeah, so it's a nested class in here. So technically it doesn't... Hold on. Is it even this one or is it another one? Okay, so you have all these here. Yeah. So those names are all going to be different because the random name changed. So that makes sense. So it's not incorrect names. They're just different. Yeah, because all the rest is the same, like AV frac and stuff. Okay, now that means I can, well, is it actually much lower? That's the main reason I didn't do it. 1.2 for initial. Oh, that's for create. Well, it's not slower, and it finds more stuff. Like it's 85% now, so that's good. But I'm not gonna turn that on just yet. Maybe later. Alright. So that's good. Good. No, that's not what I'm gonna work on right now. So I'm gonna basically repeat the initial match thing. Right? So it's finding all the unmatched ones, unmatched types. And it's just going through them and matching. Yeah. Now, right here, what I'm doing is going over all the matches and removing them from the source. That's a pretty ugly thing. I think it's better to just make a queue of the removed ones. Var removed source types, new queue of matchable type. No, and queue. Now I can also speed this up by not using a queue and just using a list. That would make more sense. But this is pretty. So also, no, that wouldn't be type safe. But this clause isn't type safe to begin with. So I could reuse this queue. But I don't need to. Like, it's not a performance thing. Why am I saying this? First of all, check if this still works. Seems to work. Find type matches. So this will basically just type match. Match the types. Right, that's what it does. It's not initial anymore. I'm just gonna duplicate this. Stats 2. Actually, I can just do this. Ah, this song is pretty. Really pretty. Cool. Okay, honk. Yes. Hi. I am no longer talking to myself. Look, my matcher works really well. Like, actually really well. Give it a second. Oh, okay, it didn't improve. But yeah, look, it matches like 80% of the types over the two binaries. And they are actually correct. Now, if I look at this, so it increased it a little bit. A lot of new fields. Now I don't... Okay, if I do turn off the top level only, right? Just run. Ta-ta-ta-ta. Well, 85 didn't increase again. That sucks. Would be cool if it did. But it's a bunch of them that have 0 matches and that have multiple matches, which is a problem. So these are the ones I need to manually fix, I think. So basically running it again just doesn't work. Doesn't help at all. That's a shame. Although it does work, because it increases the amount of fields I found, I think, when doing it the second time. The auxiliary matches. Huh. So I can just remove those again. So now, alright, one thing I want to check is with the methods. There are cases where, actually I think it's, did I close the spy? Crap, reopen it. When it does, like in module you have, where is it? Private image mutation details, as these, they're used somewhere, right? In fields, I guess. So I want to match these, and it shouldn't be very hard. So I need to, where are these used? First, back. These are used only there, I assume. Yeah. Okay. So then these aren't matched yet. Come on, what am I doing? Used by this. Okay, so I need to check the... It's like the default value or something. Or is it... No, it's the constructor, right? I think the constructor... Of course I can't see it, because, you know, the nspy. Yeah, I'm gonna set it to IL and then I should be able to see it. Are you finishing the matcher for OS? What do you mean? Wait, are you Jan? Or are you not Jan? If Jacob, aha. No, I'm writing my own matcher for OS. But it's not just for OS, you can use it for like anything basically. If you have, if you're reverse engineering a VM, and you annotate it to VM, you can just port over your mappings to the other binary if you want. Like that would just work. Oh, initialize array, right? So this is a load token. I don't know what the parameters of load token, but seems useful. If I do this, that's a field definition. Oh, of course there's a problem if you have multiple, right? So I need to, like, load token and call, I need to basically connect those with, like, I guess, what is it? Like a control flow or data flow graph, because I need to know that when you call initialize array, you can connect, hold on. you call this and then you store it in this. Yeah, okay. So you load this field, call initialize array, and then store it in this field. So I need to link this type and this field in some way. I would think. Problem is, because if I have multiple of these field definitions in a method, I won't get exclusive matches because it doesn't take order into account. I need to write this down. So you have token array value. You have call array, and then you store into my, like this. Okay, so if you have these multiple times, 2, 2, 3, 3, those fields will only be used in this constructor. They just, or these, right? The array value fields, because they're literally just holding a value and that's it. It's the only thing they do. The only reason they can be linked to this static field is because this init array call is called and it's stored in there. So I really need to have I need to like use echo to get a data flow graph. Which is, look, it's like if I don't, because I will just have a bunch of these array value things, and I can't match them exclusively over because they're not linked to a field, which would make them unique. So I need to implement a step where I go through every method, look for this initialize array kind of thing, call, and if they store to a field that's mapped, we can map the token. So I really need to have either my own stack emulation thing or use like Echo's data flow graph. Making your own stack thing isn't very hard, but it's very annoying actually, because you need to like make a queue and like push stuff, or like a stack and like push it and like emulate every instruction and I guess I'll do it myself for now, because I don't want to pull in Echo and it's like massive, not massive DLLs, but like bunch of DLLs, and it doesn't seem very, for something like this it's pretty simple. But yeah, there's already gonna be an existing thing, but it's not hard to implement actually. Like you just emulate the stack, you already know the stack behavior for every instruction. So you just making a data flow graph is really simple. Just need to think of how the API would be. So you would pass it in a bunch of instructions, and you want to find call array, where it gets its value from, and where it stores it. Problem is LD token could be obfuscated. Oh, if it's obfuscated, we'll just like ignore it, I guess. Like if this just gets a token in some special way. Yeah, like it's a runtime field handle. Okay, so I just make let's first see if there's anything else I need to push. Probably not. No, right? So you need to make a class that emulates the stack. And I need to find the dependency, no, the origin and the destination of anything that goes through init array. Okay. Let me just make a class then. Well, I don't... Can I just put it in match utils? It's gonna be a long method, but... Let's see, public static void. Find array initializations. Yeah. And I will get a method body. Method body? Sure, method body. Body. Because I need... Does the body have a return value? Oh, CIL method body. Huh? What is it then? Manage method body? CIL body, of course. Does that have return? No. Because that's another thing. Returns can, well, pop something. Okay, what else is in body? Because I only need the instructions, right? Oh, that's another thing. What if they put it inside of a, what's it called? A variable, a local. That's annoying. Also, control flow is fantastic. That's right, control flow. I first need to, like, that's the thing. I really should just use echo. That would be a lot easier. But it's not on NuGet yet, so I need to pull it in manually. You know what? I'll just add a to-do. Let's remove this comment. Do I really make an emulator? So hold on. So the thing is, I need to handle control flow because you will be able to split up, which means I would need a visitor. Otherwise I will have infinite loops. Or I can just discard them because I only need a really simple emulator technically. Then also exception handling blocks is a thing. Because they are like separate blocks. Oh god. So control flow is something I need, and exception handling, because you can randomly jump out of stuff, and like exception handling have their own control flow and everything. So so basically you would, for every block, yeah, because I can make actual control flow blocks. hold on. So there's two things I can do. First of all, if I have a function, right? I can step over every, just like act like I'm the caller and just step over every instruction. Whenever I find a control flow one, I basically split up and do both of them, right? And then when I come back to something, to an instruction I've already visited, just stop and ignore it. So it's basically walking all the instructions. Walking the method, basically. Otherwise, I can also create control flow blocks. And then for every block, I can say it returns this value. Or like it puts this on the stack and pulls this for every block. But making blocks is a bit complicated. Not complicated, but you need to take a bunch of stuff into account, and it's not like trivial. So I think it's just walking, which I think is called a visitor. I don't know. You just walk all the instructions. So emulate control flow exit if so you're gonna fork, right? Oh right, and then when finding fields rights, check if source is call array or initialize array or something. That's what you can do. That would work, I think. I would have to store it, like if it's a initialize array. I would also have to handle duplicates, right? Otherwise, I would probably, I could handle fields. No, not fields. Locals. Well, maybe fields. But those are things that would help with like compatibility with obfuscators. Also, maybe, I doubt it's ever gonna happen, but you could throw the thing. I don't know if it's possible, but you could try to throw the token. So you load the token, you put it in, you push it, and then you throw it. Then you get moved into exception handler block. And then you could store do initialize array there and then store it, which would not be caught by this, which would be really annoying. I can try to emulate throws as well and fix that, but then they can still just put it in a method, and that method will throw the token. Hold on, I'm gonna ask Washi. Okay, let's see. Add wash. Hold on, I can show this, I think. Yeah. So at Washi, can I do LD token field throw? My handler. There. Now I'm gonna move it back in case someone puts something stupid and tries to get me banned. Now we just wait for Washi to respond. Oh, he's responding. Okay, let me move this back. Only if you wrap it in an exception. Okay. I see. Which is a runtime type handle. So it is possible to thwart my fantastic emulator, but that would also not work in Echo, so whatever. Link arrays to their what's it called? Like static array init type, whatever. That's incorrect. Let me hold on. My exception e dot type. There we go. All right, so I'm guessing that's not a problem. Oh, hold on. Echo should catch that, but not if we create a function where the exception gets true. Unless I spider down all functions, which sounds awful. Isn't this the best stream you've seen? Me typing in chat. Oh, apparently I've been pinging. Whoops. Apparently this has been running for a long time and are like 23,000 pings. Huh. Let me close this. Alright, so that's... I'm just not gonna do everything then. So... I'm just gonna assume people have the normal initializer stuff, right? Because I don't know how I would do it otherwise. This is probably fine, yeah. So this is what I wouldn't do. The thing is, making the exception handler blocks is actually kind of annoying. I did that before, before Washi released Echo. And then splitting stuff up in exception handler blocks. You get like handlers, you get parts that aren't in a handler. It's a pain. Although, what I can do, because a handler should always end on a leaf, right? So you have nop, try, catch this, right? And then you have your nop, and then it should be a leave to x, and then like x is here, and this is probably a leave too. I think. I'm not sure. But this is control flow, so I can just follow this. I don't know about this. I really don't. But it's probably ends with a leave as well. Is there any place where I have a try? No? Oh, try. No. Try. No. Try. No. Come on. Give me a try somewhere. Where is there a try that I know of? Well, not in here, probably. Ah. You know what? Never mind. I'm gonna assume it ends on a leaf. Now, this sounds really slow doing the emulation stuff, because I have to do it for every single method, which is not great. So I don't think I will do it today, at least. There may be easier ways to do this, if I think of it enough. I'm gonna save this though. Let's see, where's my... Let's see, matcher.net. What do I call this? Matcher.net. Find field init types. Okay. Add, what is this, a stage, I guess? Find field init types. See nodes. Nor don't see nodes, whatever. I'm just gonna add this for now. Yeah. Where is this used? Oh yeah, I can also do the same optimization here, can't I? No, I don't need that, to be honest. Nah. Okay, what is my to-dos then? I already did this elsewhere. So type equality, do I need this? So what was the idea here? So match registry, I already have that, don't I? Match collection, yeah. My type has that. Maybe equal, that's the deep check here. So I can remove this command as well, because that's what this deep check does. Let's see what else do I have. Oh. Deep check there. Events, yeah. Find equivalent match type. Match against it, that's already done. Cool. Now everything is just implement events, basically. Okay, let's just commit this. I didn't do much in this commit, but yeah. Wait, what did I change? Oh, okay. And also I changed this to not be top level. Don't check, just top level. Okay, cool. Let me just double check now that everything is good. Let me run this. Now it means I have 52 matches that are bad, which is okay. They're not bad, they're just different naming. Because they're like like nested types whose parent type has a random name. But 85% types matched is really nice, I think. But I want to know now, what are the ones I didn't match? Because maybe there's an easy way. I checked this before, I'm pretty sure, but... I should have removed this. So first of all, incorrect names are all... yeah, random names. These are randomized. These are, yeah, exactly. Wait, hold on. Well, these are all pretty okay. I'm gonna change the to string though, because this is really annoying. Like having to open all of them. So I'm gonna remove this. Return dn with the string. Okay. So now that should be better. And we can do the same here probably, but for the type sig. Okay, so now when I look at the incorrect names, I will get proper names. And I can see these are all from the randomized stuff. Yeah. That's also randomized, and these are just... I don't know. I assume they're randomized, because they are garbage. Let's see. Canlibdef and an MD token. Copy. Oh, I closed it again, of course. And I have the wrong one open too. This one? Okay, oh, that's a struct. That's not good. I mean, the field name is the same. Oh, it's this maybe? Because that's an interface and it randomizes interface names. So that's probably good. Because otherwise there's nothing wrong per se. Okay, now what are the unmatched types? Right? So these are the matches, which all seem good. I mean, they are good, I checked for it. Unmatched source. Okay, that's the static initializer stuff. That's understandable. That's the delegates. Okay. That's annoying. That's the display class. That's also a delegate, I think. I don't know. I'll probably look at that later. Like, this is a struct, right? Why can't it find a struct? What's the token? MD token. Oh, it's not a struct, okay. It's that. Now, why can't it find it? Is there like multiple of them? I think there are. Yeah, these all have like, no, not the same, but like this one, file read proc, file stream, no. There's probably some that have similar names here. Okay, which was the one I was checking? I already forgot. This one. So that's a bool, int pointer, int pointer. Okay. Something that returns a bool then. Wait. It should be able to recognize them. Oh, it's a delegate and I don't support delegates. Because delegates have their own little thing. They have their own like parameters, right? Yeah. So that's something I can implement. If I look at unmatched and I just pick one. Am I looking at the right ones? Is that unmatched? Audio engine. Strange. Anyway. Of course I won't be able to find it now. Well, so it's a delegate. I don't know what kind of fields the delegate has. But it's something special, probably. Hold on. Types. No. What's this? Collection. Types. Unmatched. First, where the type is delegate. There we go. That's one way. Yeah, libdev. So there's the base type is multicast delegate, so that's something. Hold on. What's that in IL? So it's a delegate. Oh, is it? Custom. How does it know the type? Because if I look at this, I just see this, right? Oh, I can turn off decompiling delegates. Is it in here? Huh. I don't get it. Okay, so it doesn't have something to allow for that. That's okay then. Anyway, set your delegate. It's got a attribute. It's become visible, sure. as constructor, apparently. Invoke method. But it's inherited, right? That's also something I can check. What did it inherit from? If it's a method. Because that helps a lot as well, I think. Now, if I look here, there's the begin invoke stuff. That's something that could be. That's like the parameters and stuff, right? Oh, so that's int32. Wasn't that a pointer? Yeah, it was a pointer. Okay, cool. We just opened both of them. Still, why didn't it match? Because it should have matched. It has like a multicast delegate as its thing here. Because I think even... Hold on, maybe it is I only do auxiliary matches for things that have already matched. And maybe I don't have to. So, auxiliary matches happen here. Yeah, it's only for the matches, right? So what I can do... No, it should have matched. Even before auxiliary matches, it should have matched in this, in fight type matches. Because it's just a multicast delegate. But I'm not in the quick... Oh, in the candidate? No. Okay, so what I can do, if there's multiple candidates, check if there's one where you have full confidence. Maybe. Hold on, how are our methods matched? They do check parameters, but it's maybe equal and it's not deep, right? So, but it will return true when it's not short. So it's possible to just found multiple matches for all those delegates because they're all implemented in the same way. So if I run a full match on them, where I will check the method parameters with a deep match, then that should work. Then I will match all those delegates, I think. First of all, let's check how many delegates there are. What is the practical purpose? Well, think about Minecraft where they have mods. Hold on. Minecraft mods, you need to know the Minecraft symbol names, otherwise you're working with field underscore numbers, right? So what people do is they come up with their own names for everything, which is great. Everyone has to do that if they start modding a game, if it doesn't have symbol names. But what if Minecraft updates? Then you need to start all over. Not if you have a symbol name mapper, because you will just map names from one version of the game to the other by comparing like which types are similar and then copying the names over. That's basically it. Do you understand what I mean? Because I went over it really fast because I already explained it like, I think 2 or 3 times. Share icons? Maybe. Like, oh, I'll show the example. This is a tool by Fabric where they... Well, it's basically the same, I just explained actually. Yarn. If you look at Yarn are mappings for Minecraft. They're symbol name mappings, so if you look here, it's basically... Ah, cool. Didn't know that. But yeah, it says like this field name, like this obfuscated name is this like real name, the name we came up with. This field is that, this field is that. If the game updates, like for instance from 1.16.1 to 1.16.2, you see there's a bunch of stuff here. You will need to come up, like we'll need to do all this stuff again, but like you need to know which field it was that was initialized, which one was sys out and all that. So yeah, and you say, is it similar in theory to grouping collections of functions in code? The fuck does that mean? Grouping collections of functions in code. That's called a class, I think you mean. But yes, a class contains functions, fields, and all that stuff. And I check if like class in binary A is the same, looks the same to class in binary B, then I match them. They're like, oh, they're probably the same, and just copy over the name we came up with for the one in the first binary, we'll move it to the second binary. That's basically it. Except it's a bit more complicated than that. So, unmatched delegate counts. So how many of these are delegates? Let's see. Unmatched delegate count. Let me just continue. 54. Well, it's something. Adding 54 more types to the pool would be nice. Hold on, how much would that be? How much percent? Calculator. Let's do some math here. So 2211 is 85%. So we multiply this by 1 divided by 0.855. So that's the 100%. Now we copy this. I hope it's copied. Just be sure. So now we take 52 divided by divided by this. Okay, it's 2%. That's pretty good. 2% increase because we're already at 58. Let me make sure this doesn't fall over again. Okay, it shouldn't. I hope it doesn't. It does. Fuck. Come on, don't stop falling over. Microphone. Okay, this should be fine. So yeah, that's 2%. That's good. Adding delegate support should work. Why times 1 in calc if redundant? I don't know. That's how I think. If you do just divide by 1 over something is the same as dividing by something. Multiply by 1 over something. Yeah. Just how I do math. It's not really important. So delegates. Okay, so I need to support delegates, right? Now we do that by immediately. No, we're gonna add a step where we loop over all types or all functions and see if we can match it to something. No, we find all. So the problem first, right? We do type matches. We basically check all our types against the other class, other binary. We only handle the ones where we have only one possible candidate, right? Which is like 70%, so it's not bad. But it's because it speeds up everything. Like the remaining 20% have multiple matches, which we get through the auxiliary matches here. But what I can do here, I can add a boolean, handle multiple matches. The problem is we will have enums which match like everything, and that's awful. So we can't do that from the start because we will like explode in complexity. Actually, most of this is just bookkeeping with all the stats and stuff, isn't it? If I copy this method over and just make it simpler. No, has more. Handle multiple matches. So I would go here. So I'm working manually with an enumerator, right? Which is not great. But it's fast. Doing it for performance reasons. I don't know if they matter, but whatever. So actually it doesn't, because here we do move next, so yeah. Really, it doesn't matter. Except we don't allocate, I guess. That's good. Man, why did I use enumerators? It just makes stuff more complicated. So what I want to do, if we do have handle multiple matches, I just want to basically, well, handle them. So this is the first match we have, and then this matches enumerator.current. Then for our second match, first match we already have, and then we need all the rest of the matches. So just gonna make, I wish I could make my own enumerator. And I threw away the yield method, so that's annoying. Can I concat? That requires another enumerator, right? Yeah. Isn't there like, oh man, append? Yes, append. Yeah, there you go. Okay, and then second match, and I'm basically. This is gonna be so slow. Yeah. Well, most IDs do that, I think. Most good IDs, at least. I'm trying to think, like, I need basically all of them. What can I do with enumerator? I can do move next. That's it. Okay, I just will duplicate some code then, I guess. So I'm gonna make for each match. So this is a matchable type. Matchable type. I will have a confidence. So and I will dig.add first dot match and first match dot is no. Oh no, but we do it with everything, don't we? No, source type? Oh no, we compare it with source type, okay. We do match with, whoops, source type, right, and then this will be the second match. Okay. And then while enumerator dot move next this. Okay. So now we will have a dictionary. Is this acceptable? No. Okay. With all the types, and we can just find the highest confidence or lowest confidence. Actually, I have a util for this, don't I? Like finds. has multiple. Find single, yes. So dict dot cell where the confidence, the value is fully confident, so where we're sure it's like exactly that, and the others aren't. Which, to be honest, isn't actually a good thing to do, now I think of it. Because we're gonna have false positives this way. But if it's really the only one, I guess it should be fine. Now find single out pair. Oh, var pair. Okay. So actually, let's just make it nice. I'll only select the keys from this. Perfect match. No, sol perfect match. So maybe do this. Okay, cool. So now we know there's only one match. Then we can basically do what happens here. Match manual. Source type with a sol perfect match. Remove this match and remove this source type. And then what do I implement? Total matches. Okay. Oh, this is wrong. No. It should be fine. I'm gonna keep it like this, it should be okay. So basically we just do the same we did before. Let's run it and see if this improves anything. I really hope it will find stuff. Stage 3. Find matches to allow multiple. Okay. Fingers crossed. Let's hope it doesn't crash. I don't think it improved anything. Yeah, I'm comparing it to what I had and it's basically the same. That's a problem. Because this should have matched delegates. Because that's multiple matches, right? But none of them are single. I see, so none of them are full confidence. What? What do you mean? Where is it converted to an integer? You mean like this? You mean this or what? Like I'm just making a dictionary, which is like a set of keys and values, like an actual dictionary. I'm storing the first match in there along with its confidence, which is just an integer basically. It just says how certain are you about something. Yeah. Same with the second match. Store that, and then all the other matches we just store that inside the dictionary. I was gonna do this anyway, so may as well. Wait, that doesn't get hit. Huh? That's not right. Why doesn't it get hit? Huh? That is strange. Did I not start the debugger? That should... that was true. I said it's true there, didn't I? That's true, that's false. And it's... Oh. Oh. Ah, okay. I think I just didn't... Maybe most try to convert variables. It's a generic, it doesn't try to convert anything. What is storage? No, I think you just don't really understand how generics work. Like, a dictionary is of type this. And this part basically means that you can change key and value with like whatever you want. So for instance, one of the methods on dictionary is try get key, right? Or let's just say contains key, right? And the signature of this is bool contains key t key k, say, right? Because dictionary is generic, we don't know this value like immediately. However, if I make my own dictionary, like I say var my dic equals new dictionary of say int and string, we actually sort of fill these in, right? We fill in the key and the value. For instance, the first one is the key, so that would be an int, and value would be string. So we get suddenly this method gets converted into basically this bool contains key int k. Same with there's also the value one, contains value, which would normally accept the value, but it's a generic and we filled it in with string, so it becomes this. Also that's value, whatever. So that's what a generic is. It's like a type you filled in yourself. So if I look here, I have my dictionary, my key is matchable type, my value is confidence. Like if I look here, t key, t value, right? That's what I do here. So basically here when I do dot value, because it's the key value pair that comes out of dictionary, it's of type key value pair of matchable type and confidence. So the value is confidence as I declared here. Oh god. Yes. Hi Washi, welcome back. This means you can fill the key and value types on the fly via top to bottom inter. What the fuck do you mean by top to bottom interpreting? If you don't know what you're talking about, just don't mention it. It basically means that when you create an instance of this type, you decide what those generics are. Like you say the key, the t key type is filled in with matchable type. No, it will read everything, turn this into tokens, then turn it to an AST, and then go from the... It's like a tree structure then. It starts from the bottom of the tree, which would be the namespace, like the namespace, and then it will go here. And it appears like top to bottom, sure, but that's not really how you should think about it. Tokenizing is from start to end, that's true. But yes, when you analyze AST, it's different. But it doesn't matter, it's not relevant to how you program, it's a compiler implementation detail. it's locked into the type one is defined. So if I make here a dictionary here, say it's these type, then this instance of that dictionary uses those two types. Just like if you make an array, it's an array of a certain type. That's like the same. It's like you can see an array as a generic type as well, or a list, or whatever you want. Hey, Iridium. All right. Anyway, let me just turn these off and see if it actually improved something. No. Yes. After stage 3, so that's the same. That's the same. Same. Okay, so it didn't actually improve anything. That's sad. So let's see what values get through here. Okay, there. I just hit F8. So now we have 2 things in there. I want to see what they're... They both have 100%. Ah. So my confidence thing isn't harsh enough, because this matches sharp ziplib dot update command, which is a type, which has one field, which is an int. Right, and nothing else, because it's a simple type. However, it is nested, so it should be able to figure out that its parent is matched. Maybe sharp ziplib has, like the zip file thing, has multiple nested types. Zip file. What's the name? IC sharp code sharp ziplib. Okay. Zip. Zip file. This has some extra types here. So the one I had was update command. Oh, that's an enum. Okay, I see. That's the problem. Enums. How do I... So it's used in all these, right? Why doesn't it find those then? Because if you look at this in the IL, that's a new object call. Oh. So that's, yeah. So if I do new objects, it calls a method. But I already... Maybe I should make it so that get auxiliary references returns a dual... Jesus Christ. It's just reenacting the entire skit. Alright. So I can make this return to... I'm just gonna make a note here. So this is just like maybe I should add sort of discriminator to each thing. Hold on. Oh, nice. All right, I'll allow that. There you go. Also, concatenating is not a word, but concatenating is. Concatenating there. Concatenating. That's the word. What type are you getting? New object call for return from I don't know, something else. So that's something I can change to auxiliary references so that they can indicate. So I can basically partition them into different things. Yes, so I can partition them into different enumerables, and that way I can do 3 times. Yeah, that's what I can do. What did I update here? Because I have a bunch of changes. I don't know what they are. Oh, I changed that. Okay, so that's something I can do. I can partition the returns stuff. So what do I partition them by? So I can do integers. Oh, why am I using the nlib? Because it has less hidden features. I remember earlier, like the earlier stream today, I think he was Skidrod. Skidrod, he asked me why I wasn't using Asm Resolver, right? And then I finished my stream, I look into RTN chat and I see him complaining about a bug Asm Resolver has. So like, I think that answered his own question. So yeah, there you go. Okay, so for this auxiliary reference, so I think I want to return, I think a tuple of integers, maybe? That would work. Jesus Christ, alright. So I want to go to this. Get auxiliary references. Every returned in libdef. Comment, hidden features are a euphemism for bugs. But they're really like Easter eggs, you know? Like when you find them, you can be like happy and like say, look, I found it. And it gets removed because, you know, it's an Easter egg. Once it's found, it's not funny anymore. So bugs are basically Easter eggs. So every return to unlit ref is paired with a... You rehide them. Oh yeah, that's an idea. Yeah, you can put them in a different place. That's true. That's I should take that mentality in my software. Just hide them in a different place. Oh. Every return to the dev is paired with a discriminator, so they can be processed in parallel. Custom section in my executable. Exactly. About 11, sir. Jesus Christ. Alright. I can see my bitrate drop down randomly. Oops. Let's see, and then I think I will use an int for a discriminator. I think that's the safe thing, because like it's a discriminator. I can just define some constants. If I just take anything that is I equatable or whatever, that's not great. So I think an integer is probably the best bet. Just keep it simple. No. Even if you have good internet, I'm behind a power line adapter. So no. Generalization next level, exactly, it's an integer. I mean, it's a discriminator, right? Whatever. It will be clear. I just need to copy this now and do this. I can do, well, the thing is, you would do this like const int fields type equals 0. There. I don't know how you would do this in a better way. Is that? Oh, really? Okay. So that's what you do, you like make fields. It's not the prettiest way, but it's I think it's kind of elegant, okay? Because like the caller doesn't need to know what it is. It's just a discriminator. Washi, if you have a better idea, I would love to hear about it. I'm gonna need to copy this. So method. Oh, okay. I thought you were commenting on what I was doing. Sorry. Yeah. It's parameter. CF param. I don't like how their names can conflict. Return. Oh, you're gonna love this. Okay. Okay. So we're gonna do parameter is hidden this. Oh, there's a normal one as well. Not hidden and not, yeah. So if it's a hidden this kicks dick. Okay. If it's hidden this, then return this parameter. Otherwise, if parameter dot is return parameter, return parameter. Otherwise, normal. Oh. Okay, now I do want to format this a bit better. There you go. Oh, what the fuck? Oh, okay. Really, dude? I'm gonna get like a copyright strike because you're putting the script of like a movie in my stream. Well, I don't know if it's part of a movie, but like, All right, that's discriminated now. Now, oh, this is 1, 2. His name is inspired by Pokemon. His name isn't inspired by Pokemon, I think. Wait, Washi? Oh, wishy-washy. Okay, cool. Oh, really? Okay. Well, you named your bot after it, at least. So that one was coined afterwards. I think as discriminator, I'm just gonna use the instruction type. Because if control flow changes, the instruction type won't. If it's a new object, it's gonna stay a new object. So I think this is a good one. This is a really good one, I think. A good way to improve it. Alright then. It's still wishy-washy design. Yeah. So instruction.opcode.code. Can I just cast this to an int? Oh yes, there we go. Best discriminator ever. What's the highest one? Read only? Okay. This is the beautiful, okay. I don't know why, this is just so funny to me. Alright. Okay, so I have like a PM open with someone, like in Discord, right? The first message I see when I look to my right is this one. I'm just gonna close that again and continue working now. So I'm gonna go continue to property. Oh, what did I do in field? Oh, no, I'm gonna copy this. Property. Alright, field. Okay, so this doesn't really matter, right? Let's see, const int. I don't know what experienced programmer has to do with doxing, by the way, but sure. Const int field discriminator. I don't know. Is field. This is like stupid. Why am I doing this? I can just make them all the same. This method is type. Nah, it's already below here. Okay, so is type. There we go. Now that's discriminators added. Oh, is event maybe. And then I can. Will this replace? No. Nice. Huh. Okay. I mean, you can be a very experienced programmer and still a script kiddie if you don't know the ways of the hacking or something. I don't know. Sorry, I just... I just have this massive list of Watasho memes now in PM, and it's hold on. The other ones aren't like incredibly good, but it's still funny. All right. Is that new? Hold on. I'm pretty sure it's not new. It's like it's sent to me in like July the 6th. There's also some classics in there, of course, but they're not like terribly funny. They're just good quotes. Just like this one as well. Some others, but I don't even know where this comes from. Like, I don't know. Oh, this track is good. Pelipper Island. Okay, good. Fish Nick no Washi to Watashu Sensei. He's alright. I mean, you can change your own nicknames, so maybe I should take his permission to change his nickname and then change it myself, so it's like stuck and he can't change it. I should test this out. Okay, hold on. Oh right, I can remove all this stuff because it's not actually useful. Which is a shame, because it's a lot of code. First doc. Yes. Okay, so select, resolve. Now, is there a partition? Please tell me there's no partition. Let's see, C sharp. No, it's group by, I think it's the C sharp name, right? Group by. Huh? Wait. Oh, no. Okay, I see. It's on the wrong thing, right? So to resolve the unlib def doesn't work because this is now by discriminator, right? So now we have, I don't know, a group or something. I don't even know what you can do with this. I never use this. So let's select. So what do I have? X is a key. Oh god. Can you change it to like a dictionary or something? Okay, it's a key, but it has something else. It has an enumerator over this. Okay. The only thing. Okay. I mean. Oh, come on. Fuck you. So I can iterate over the first group's discriminator, because if there's a discriminator that's in the first, not in the first one, but in the second one, that's useless and I can't match it anyway. So it should be safe to just iterate over this. So oh, come on, how can I just do 40? Source refs for each, come on. So that's apparently value tuples. Groupings, I guess? No, that's a grouping. Okay, and then oh, okay. So grouping I don't care about what the discriminator is, so I can just do numerator. No, just grouping for each. And I can... No, I don't need to do that, because I can do find new exclusive matches here, right? So just copy all this in there, right? Now we have grouping. So that's enumerator, not IEnumerable. But can I even? Come on, just work. But that works actually. So it's multiple enumerations. So that's not what I want then. So I would so that's the source group. And then target group is I still need to resolve the endlib definitions as well. That's a pain. Okay, there you go. And then okay. Alright, sure. Goodbye. So this is being enumerated, that's good, right? And then to list. Now what is that type? It's a list of groupings, right? I want to change this to a dictionary. Does that work? Oh, I can do a key selector and a value selector. All right, and then I think that works. So that's dictionary for integer and grouping. Right, so sort group is that, and then target group equals, this is awful. Grouping key. So now it's a grouping of this. And I can just do the same select on there. So now I also have a list of matchables. And this should be equivalent of the previous one, except it's now discriminated by grouping. So now, can I make this clearer? So you get auxiliary references and group them by the discriminator. And the same here, except you also make a dictionary by key. So this is slow, but it's a small workload, so it shouldn't really, it's on small amounts of data. So that's target group. And that's source groups. Okay. Okay. Let's just run it and see what happens. I expect it to be quite a bit better. It's like not changed at all, is it? No, it changed like a little bit, right? So compare like types, we have more types now. We have like 0.5% more. Fields went down. No, went up. Okay, no, I was looking in the wrong direction. Okay. Property is the same. This is like a bit more, like 0.4% more. So that's not bad. But I don't know, I kind of expected a lot more out of this. But I have less delegates now, at least. So that's one thing that I fixed. Although, really though, is this only the only increase? I mean, I have like 600, I have like 4% more fields. So that's something. But I expected a lot more. Well, a lot more. Well, it's happens, I guess. I mean, I don't know if anyone was there to see it, but a while, like earlier, I made a change, and I went like from 70% to 85 with like something I didn't even expect to work. So there's that. I thought it was a bug at first because it was such a good improvement. Anyway, so that's, well, let's see. Add discriminator to auxiliary. Well, it was a feature in this case because it actually worked and it like helped a ton. And it basically got rid of all the invalid matches I had, I think, as well. But I'm not sure about that. Or maybe just match different things, who knows. Let's see, type. Yep, seems good. Oh yeah, this was like work in progress comments, they can go. Oh, I removed that, okay, I can live with that. And I do use opcodes here. Okay. Actually, the good thing to do would be like x plus something, now that I think of it. Where's that matchable method? So it would be 0, 1, 2, and then opcode offset equals 3. So 3 plus this. Alright. That's good. Yep. That's for type. So, yeah. So maybe I should also return the parent type. I don't think that will help though. Alright, whatever. Type reference. Yeah. Checkboxes. Yeah. Well, you can also say like, I only want to commit this line or these changes, you know. So, oh yeah, I added an extra step, but I don't know if that extra step actually did anything, so I'm gonna double check. Okay, so stage 3, stage 2 are exactly the same. So my extra step didn't help at all. Find matches with allow multiple, yeah. So I want to double check that actually, because it says it has a lot of them that are multiple matches. That was all good. I really shouldn't be committing multiple things at once, but whatever. So I want there. So I'm gonna see when I do my third pass where I also check cases where there's multiple matches to see what I found. So these are all enums, I'm pretty sure. They're enums. Okay. Hold on, what if I just don't do it if there's an enum? Or is that a type or something? What am I comparing it? Source type. Yeah, source type. The enlib is enum. Okay, now watch me get like no matches at all. It's only enums that I find. Okay, let's see. That's two of them. And they're very similar. They're both perfect match. Confidence 100%. Wait, did I do a where confidence? No, right? No, that's what I do here. Yeah. So that's one field and that's an integer just like the other one. Now, which one is it? And is there a way for me to detect it? So this is a state machine. No, is this? No, it's a handler. What is this class? It's a nested class, right? So that means there's two nested classes in here that are clashing. Or there's a bunch of yes, a bunch of nested classes that both have this implementation thing. So what I can do is also return not just things I find, like right now what I'm returning from auxiliary references is the nlibdes, but if I also return type references to external types, like this, that would help a lot. Because you have this thing here, which is... Because if you have two methods, like, hold on, where's my notepad? What I have right now, I have class X, class Y, and they both implement the same method, right? But one of them is gonna have a different implementation that maybe refers to different classes, like correlate classes. So I can check the implementation and find all the types it refers to, and return those and compare those. And that way I will be able to find the difference between these two. Because like say this one maybe just console the write line, this one is read line, I will be able to find the difference. The downside is if there's many changes, it will immediately pick up on them, which maybe is a good thing. But yeah, that's the problem here. At least with this specific one. So let's see, continue. Now we have 37 types, which is probably another enum. No, oh no, it's these. Yeah. It's the field initializer, which also I'm gonna fix in the future. Same thing. Yeah. All right. I see. So another thing I need to do then change auxiliary types check to return to allow return so this will allow me to check more stuff. Problem is like right now I do the nlibdef, which is, well, only the nlib definitions, which is internal only. So I would need to change that. Which means I also need to considerably change my implementation here. Because now I convert them to, what is it? The nlib definitions and compare them. So these would be something else. Wait, I'm not using target? Huh? Whoa, whoa, whoa. Why? Oh. Oh. That's probably why I didn't change much. Haha. That was a hidden feature. It should have like mismatched a bunch of stuff. Oh, come on. Okay. I would have been embarrassing if I committed that. How long was that in there for? Jesus, okay. Parallel stacks. Huh. Am I removing from them? Wait, where does that come from? Oh, I need to check myself, yeah. Alright, I'll click it. Okay. Harem Scouter. Where does that come from? Actually, I think this would be fine having a different length. Because no, it shouldn't happen. Right? Oh, right, the harem thing. Yeah, I remember. Like, where's my harem, I think I said, yeah. Okay, so there we have our source group and target group. Oh, because I check if these are the same length, right? I think. So that's 10 with a bunch of keys. And this is also a 10. No, that's wait, that's 10. This is 11 then. There. Yeah, that's a. Why does this start at 1? This is not Lua. Well, it's a dictionary of an integer and something else, but even then, that's Wait, now it's. Am I stupid? Oh no, that's a dictionary. Oh, and yeah. Okay, so that's then. For some reason, this is just one indexed for whatever reason. All right, sure. Anyway. So I don't think it really matters if I have if there are different numbers. Jesus, that explains why I never had a mismatch yet. Oh man, I feel so stupid. How long was that in there? Oh no. I feel so stupid. No, yeah, well, there's my mismatches again. My god, this entire time I had a bug where I was comparing at the same binary. Comparing to the same binary. I really need like the add match thing. Hold on. Assert source, libdef module Oh, come on, tell me there's a module. No? Alright, whatever. So, this went down, my efficiency, because I fixed the bug that caused false matches, or matches with the same thing, same type. So how that went up? That's strange. Oh well. Oh, that does go up. So my second iteration is useful. Hold on. Everything off. So the bug was here. This fixes it. Fix. Find new. Ah, shit. Find new. I really need a proper microphone. Or a stand. Find new. Just matching against itself. Okay. Alright, so this is the result, right? Okay. So types went up. This stays the same. So we get more types now. With the third stage, at least. Amount of delegates stays. No, went down. That's good. But there's still a lot of them, so. Add discriminator to outer. Let's just allow finding multiple matches. This can go. Allow resolving, I guess, multiple matches. Alright, sure. So I should really go to sleep now, because I have work tomorrow. I need to get up at like early, like 7:30 or something. And I've been streaming for almost 5 hours now, including the 2 hours I streamed before. So people that ask me to stream better be happy. I'll have seven viewers for now, of course. All right. I'm gonna copy this, put it in my notepad. Okay. Cool. So I'm gonna probably end stream here. So yeah. Meet pause music. Yeah. I don't know if I'll work on this on my own time or not, because I don't have much time. But we'll see. So yeah, see ya, I guess.